Integration by parts. Integration by parts is a very commonly used integration method in integral calculus because it works most of the time and is the basis for deriving many formulas, notably the reduction formulas of sine and cosine, which will not be presented in this video. We will first consider how it came to be and then discuss its application. This method of integration supports itself from the concepts viewed in the fundamental theorem of calculus, as well as the differential calculus, which should be reviewed beforehand. Recall from differential calculus the product rule. The product rule states that the derivative of f and g, where both functions are multiplied together, equals to the derivative of the first function f times g and the derivative of g times f. By algebraic manipulation, we can throw dx on the other side to obtain d of f and g equals to f prime g dx plus f g prime dx. This is because differential can be thrown around the equation like any variable. If we let u be equal to f and set g to v, what we naturally obtain as their differential through differentiation is f prime dx and g prime dx. When we replace what we have here to the former equation, we get d of u times v equals to v times du plus u times dv. Integrate both sides. By the fundamental theorem of calculus, we know that integration is the reverse operation of differentiation, and thus we eliminate d with the integral symbol. We swap sides of what we obtain to get integral of u dv equals to u times dv minus integral of v du. This is the formula for integration by parts. The formula of integration by parts is used to simplify otherwise more complicated integration problems by setting the two variables, u and dv, to appropriate functions. If we observe the formula, we see that u is differentiated and v is integrated to obtain the value on the right. When using integration by parts, we follow some tendencies and golden rules. Generally, you tend to differentiate polynomials and integrate cyclic functions like e to the x and trigonometric functions. The first golden rule is to always differentiate logs and inverse trigs. The second golden rule is to always do long division whenever possible before performing integration by parts. Let's go through an example together. Suppose you want to solve the indefinite integral of x sine x dx. You will set u to x and dv to sine of x. We find du to be exactly 1 dx and v to be minus cos of x. Therefore, using the definition formula, you get u v minus integral of v du. That is, minus x cos x subtracted by minus cos of x dx. That's it for this video, and I hope you found it useful for your purposes.